Good evening, ladies and gentlemen. The last time I had a talk here, the trend was sort of moving towards having a presentation in English, so all my slides are in English and the notes are in English, but I'm willing to risk an informal poll and ask, would you rather have it in German or in English? I don't really care. Who wants English? Okay. German. Well, that just solved nothing. Okay.
Also English.
Well, I'll tell you what then. We'll start it off in English, and maybe once in a while, just to confuse you completely, I'll switch back and forth between German and English. English would be better for me because thousands of people are watching me right now worldwide. I'd like to say, hi, Mom. Enjoy the show. My presentation tonight is called Cost Underestimation in Software Development, and for me, it's an interesting subject because it's one I deal with every day. Unfortunately, it's usually the source of a lot of sadness and frustration. We are slowly, very, very slowly, in the IT industry, developing the necessary mechanisms to estimate our software projects properly using all of the team members. But it's been a long, painful journey. So, most of the estimations I've seen in my personal history, which is about 20 years now in the IT branch, have been estimations and have been brutal underestimations. This presentation is a mixture of personal experience, project analysis, and research into the methodology of estimation. In every project I've ever encountered, the core question is not, can we produce functioning software, but how much time and effort is it going to cost? Everybody, the entire team, has a big responsibility in the project, but nobody wants that responsibility. Ironically, even though all of the team members play a role in the project, especially in generating the levels of complexity which run the project, it is the developers who are required to put numbers on it. And because of that, the methods, the problems, and the hurdles we use to generate our estimations are the sources of many, many interesting stories. This presentation divides itself into the psychological aspects of project estimation, the difficulties involved, and also the methodology we use in the past and now in the present to make our estimations. As far as the psychology is concerned, it starts off with a very, very optimistic base. Programmers are optimists. Anytime you confront a programmer with a problem, the first thing he's going to say is, that can't be done, especially not at this stage in the project. I don't want to do it. You want me to encrypt all of the database requests? No, it can't be done. And then he starts to speak slowly. He starts to look around. He's thinking in the back of his head, maybe it can be done. And any of us who ever had the pleasure of watching a bunch of programmers talk about a problem know that they are optimists. They think they can do it. They think they can get the job done. They see each new project as a collection of opportunities, as a collection of ways to prove themselves. I'm not going to lose face. It's going to be so cool. I'm going to get all the hot women, and it's going to be a wonderful project, and all the features are going to be perfect. We are optimists by nature. But the digital culture in which we work is a trap because everybody says, you work with numbers, you can put a number on the effort required to do the job. You can estimate it, quantify it, make it a number that we can use to tell the client how much money this is going to cost. Unfortunately, however, we're not changing the water pump in a car, we're generating a software project. And all of these are unique. No two software projects are alike, and no two estimations are alike. So, starting off, the project has been briefed and we're ready to get going. And the initial promising moment During the briefings, when we think we've understood the project, we've had a wonderfully detailed briefing, that's when things start to go wrong, because the parameters of the project always change. And unfortunately, the more detailed the briefing, the more waste has already gone into the project. The more that is going to get thrown away at the end, because the project will change. It will mutate. As soon as the client has been watching the project grow for a few days, weeks, or months, he's going to think of new things he wants. New features will come into the project. Things we do know or don't know will come into the project, and it will expand. Just like going into a camping store and buying a sleeping bag. You get the sleeping bag from the camping store, you take it out of its package, you take it out of the little sack it comes in, and it takes on a life of its own. It expands, it becomes bigger, and you try to stuff it back in there and it doesn't work anymore because it's got a life of its own all of a sudden. When we have the initial successes, and at the beginning of the project, the successes always come quickly. The client, the customer starts to think, well, if we can do X, then we can do Y. Can we have that done? Please estimate that. And everybody starts looking at their shoes and saying, I don't know, I have to come up with numbers that the client wants because we are responsible for the project and the finances involved. I'd like to take a quick poll at this time in the presentation. Ask how many developers do we have out there? Raise your hands, please. Developers? Okay, we're looking at about a third, maybe 25%. Project managers, project owners, product owners. Okay, about the same. Designers? User experience architects. Okay, we got just about everybody there. Nerds, hipsters, anybody I've missed. It doesn't matter. Ich werde euch alle beschimpfen. So. Jetzt muss ich mal kurz meine Notizen angucken. So. Everybody else has been talking about Donald Trump tonight, but I'm going to take a minute to talk about another Donald in American history, who is also a pretty controversial figure. It was Donald Rumsfeld, justifying the invasion in Iraq. And he said, well, there are things that we do know, and there are things we know that we don't know. But the dangerous things are the things we don't know we don't know. Can you follow me there? Any IT project is exactly the same. 3 months down the road, problems will come up that nobody had predicted, that nobody could even see. They weren't on the radar. Real expertise may be able to think about those problems, and having had experience, maybe you can foresee them. So this happens in every project, it's going to happen in this one as well. But it's the unknowns that really make projects impossible to estimate. We'll be getting into that later on. So we spent much too much time on this slide. We've got plenty more to go. We're starting up in the difficulties in estimating a project. Even though programmers are optimists, project managers, properly so, are pessimists. Difficulties will arise. Anything that can go wrong will go wrong in the project, and as a corollary, it will go wrong at the worst possible moment. Anytime you set up, we got this wonderful project team, I've got the designer finally, I've been waiting to get him for 6 months now, he's going to get sick. People go on vacation, they get sick, they go skiing, they go to seminars of the 3S. I suppose if you wanted to go back to Sperma und Titten, Sex und Saufen, keine Ahnung, everything's there. You are going to lose, at the start of the project, plan 10% of your time will just disappear because people will get sick. I'm not talking about planned vacations. People will just disappear on you. Starting to turn the optimism into a little bit of pessimism. 10% of the time. Any time. And this is where I get a little bit mad at the developers and the project managers. Somebody comes up to you and he says, this project is going to be faster than all the others we've had because I have a new framework, we have a new technology, we have a new deployment system. It's going to be so geil. Bullshit. It won't be. Because if it's the first time this is being employed, it will slow your project down. I guarantee it. Maybe the second project, maybe the third project, when you have enough expertise to actually manage this new technology, then you will reap the successes of it. A couple of other issues that they happen in every project. Okay, fine, we have a new development team down in Munich. They're going to help us out. reckon a week or two until all the connectivity issues have been resolved. So, progress in the project is difficult to measure. The measurement of time is not the measurement of progress. You don't know if your developers are writing code or if they're taking care of their Facebook pages. If they've just spent 8 hours working on the project, they spent 5 hours working on the project, you don't know. Burn down is never linear. It's a roller coaster. Wir sprechen von einer Achterbahn. And there's a big ramp at the end of it because as the project to the due date comes, everybody starts getting really active all of a sudden, and the last 20% of the time consumes 80% of the effort in the project. Please never forget that. Actual programming in any project will only consume about 16 to 33% of the time. Everything else is, well, project management, design, user experience, architecture. It's not overhead, but it's a necessary evil, speaking as a developer. Obviously, opinions will differ on that one. And this last point, if the project is running erratically or maybe a little bit too slowly, it's never a good idea, it's seldom a good idea to try to correct that by adding manpower. I'll be coming back to that point later on. Any good programmer, and I kind of challenge the developers here to refute this statement. On a good day, he might write 20 lines of code an hour. On a bad day, it'll be 25 lines of code for the whole day. Measure yourselves and see how much code, after you've refactored, after you find out what the idiot did while you were on vacation, after you find out what the client, the customer wants on new features, find out how many actual productive lines of code you've written. You'll be surprised at how little it is. We just talked about the difficulty in measuring progress. It's also difficult to control, difficult to understand how far along we are in the project and where the time is disappearing. You call up the client and trying to tell them how come the project is running late. Do you ever tell your client, well, geez, do you remember the super volcano that erupted in the Rhine-Main area and just laid waste to all of central Germany? It never happened, did it? Projects run late, one tiny little bit at a time. Termites will eat your house slowly and you won't notice it until it collapses. A tornado is more seldom, but that's a much easier problem to identify. It just doesn't happen as often. So, when we're sitting there with a bunch of programmers, all of whom are optimists, if your programmer has said, well, I got everything done today except for the last half hour and I had this tiny little problem, I promise you it'll be fixed tomorrow, if he or she even mentions it. That's a little bit that's lost. And a little bit gets lost every day, and we don't really talk about the bad details, the things that get lost. That's how projects get behind. How does a project get to be a year late? 1 day at a time, 5 minutes at a time, and nobody notices. It's difficult to find a little instance. I couldn't log in. My virtual private network didn't work that day. The design was delivered the next morning instead of the evening before like I expected. All of these little things, the optimists will say, I don't really want, the project manager's enough stress right now, I don't want to bother him. These things will eat up your project. We don't like to communicate that. Another big difficulty, especially in estimating a project, is communication. A lot of times, we think I've talked about this, everybody understood it, it was perfectly understood, I can go back to my workstation and start programming. It's never the case. Especially in estimating a project. Getting all of the individual team members to speak the same language is nearly impossible. And, as a warning, if any of you think, I just finished communicating, you didn't. You failed. Communication almost always fails. Designers, user experience architects, programmers and project managers all speak different languages. Anybody who's ever tried to set up a web project with different modules, the designer says, well, this is just a button. And the developer says, no, that's a link. And the user experience architect says, well, no, that's a call to action. And the project manager says it was supposed to be due yesterday, now it's cost 100 euros more. Nobody's speaking the same language. And every time I'm sitting there in a meeting with my developers and they're talking to me, somebody mentions a new technology, I say, yeah, I know exactly what you're talking about, thinking to myself, I have to go Google this really fast because I don't want to face the fact that we can't communicate. Many, many different languages are being spoken. So ask yourselves, the project managers, you're talking to developers, and even though it's really tough to communicate sometimes and even tougher to understand, have I really communicated? Especially during the estimation phase. That's one big source of failure. Now we're getting a little bit away from the difficulties into the methodology of estimation. One thing that we need to look at is not necessarily the amount of time, the amount of effort, the amount of jobs to be done during programming, but the amount of complexity that we have to overcome. That is the most important part of estimation. Anybody who's ever tried to estimate a job knows that if we can break down complex tasks into simple tasks, we can use our experience to put an accurate dollar, time, and effort value on any one job we do. It's not foolproof, it can mitigate the problems, but technical projects are often too complicated to be comprehended. Even experienced developers who know the project is complex might not understand the full level of complexity. So, the most important statement maybe in this entire presentation is to take complex tasks, understand that they're complex, admit to yourselves that they're complex, and break them down into pieces which are understandable. As soon as you've done that, they've taken the first step in having a project which can be accurately estimated. Because complexity is easier to estimate than effort. You don't know what your developers are doing, but you know if their tasks are complex. And if your developers are honest to you, and if you communicate properly during the estimation phase, you can take complex tasks, break them down until simple, understandable tasks are generated, which everybody can deal with. We don't want to estimate absolute values, we just want to compare, because everybody can compare something. Putting an actual quantitative value to anything is much more difficult. If any one of us was to go up on the roof of the building tonight and look out over the skyline of Frankfurt, vorausgesetzt es gibt keinen Schnee, and see the buildings in the skyline, then you can say, well, that building is taller than that one. That one's much smaller, I can see that. You may not know, unless you're an absolute Wikipedia guru and architecture fan, exactly how tall the buildings are. At that point, it's irrelevant. You can say to yourself, that building is taller. Everybody can compare. And having done that, we've taken the first step to generating a proper estimation of complexity. Everybody, something I mentioned at the beginning of the presentation, everybody says, well, you guys just numbers brains. All you do is work with numbers all day. Websites are binary, computers use numbers. Put a number on your estimation, please. But don't regard the algorithms above the human factors. Those are the parts of your project, the people who are actually doing the work, who are unpredictable. All factors which lead to overruns in a project are human in origin. If a server crashes, it either wasn't planned properly, it wasn't programmed properly, or the capacity wasn't adapted to the job it had. Success will also be never caused by technology, it will be caused by proper planning, proper estimation. Know the methods that your team is using, know your experts, and know what they can produce. We'll be getting back to that more in just a bit. Down below is my favorite algorithm for estimating software projects. I'm just going to take a quick cheat over here. It's called What the Hell Do They Do All Day and Why Does It Cost So Much Time and Money? That's the only algorithm which actually works, because that's the one we always use at the end of the project when everything's fallen to pieces. Another part of estimation which customers love What developers don't, project managers hate, is one I'm going to call play to win. That means what the market dictates is what the job will cost. This is not necessarily the responsibility of the designers, developers, and user experience architects, but it is the responsibility of the project manager. And it should be used as a constant rule to sensitize all of the team members to the base of the project. What is the most economic way of doing what we want to do? Obviously, if a web agency or a software house does all their projects like this, they're going to go bankrupt because you obviously can't undercut the market with every job you do. But if you have a sensitive feeling for what your effort is costing the project throughout the entire project, not just at the end when everything's being, when the crisis has occurred and the due dates are approaching, but during the entire project, then success will be better ensured. We're going to get a little bit of the algorithms now because I know it's very late in the evening and you really want to be bombarded with numbers. The first one is an excellent way to make your clients and customers feel happy. Unfortunately, it's also doomed to failure. The Kokomo model, I'm sure, anybody's ever heard of it? Hands up, quick. I see one. Well, a couple. At any rate, I'm not going to really go into it. The fun-looking parts of the equation is E for effort, and thousands of lines of code for KLOC, and then the effort adjustment factors, which are obviously the human factors involved in the project. Everything makes the project more complicated. And like I said before, estimating complexity, comparing complexity, is the basis of generating proper estimates. At any rate, get away from the algorithms. Realize that your project is run and used and maintained by human beings with all of their problems, errors, and inconsistencies. And you'll understand how come the classic methods of estimation are often doomed to failure. Now we're getting a little bit closer to reality here. Anytime a developer comes up with an estimation, you have to take different factors into consideration. Now we're going to get a little bit violent. Project managers, product owners, anytime a developer comes up to you, so I can get that done in 16 hours, lean across your desk and whack him. Because he's just told you a lie. Nobody knows how long or how difficult or how complex an actual task is. It's going to take him 16 hours to do. They simply can't estimate that. It's too complex, it's too big. Nobody knows what's going to happen in 16 hours. 16 hours is more or less a half a week. Initial reckoning, 30 seconds is about an hour. Let's start off with that. I had a case about 6 months ago when a customer called up and said, we have a blue background in this teaser on the contact form. I want that gray. I said, okay, it's going to cost you about an hour. And then 5 minutes later, the project manager was at my desk saying, I need you to write a little letter to the client telling me why this is going to cost an hour. And by the time I had the letter written, that was about 10 minutes gone as well. At any rate, I have to stop what I'm doing. I have to read the client's mail. I have to talk to the project manager. I have to call the client. And then I have to find out what this part of code is, what has to be changed. Then I have to upload it to the test system. I have to check it, make sure it's okay. I have to check it in. I have to deploy it. I have to deploy it to the live system. I have to test the live system. Then I have to call the client again. 30 seconds is an hour. Obviously, if I have 20 tasks, all of which should take 30 seconds, I can bundle them. But this serves as a perfect example to show you how time can expand when doing software projects. Break your tasks down. Sit down as a team and find out exactly what the tasks are. Make sure everybody can understand them, break them down. Everybody says, I can get that done in 4 hours. I can get that done in 2 hours, but no longer than that. 4 hours is our target. I'm not exactly sure why, but that's statistically the most likely part, the most likely chance of success that you'll have. If somebody says, I can do that in 4 hours, that's more or less the amount of time it's going to take. This method of estimation is called scope to time. and is more or less, in terms of my experience, the most accurate. So, like I just said, any tasks which are longer should be broken down so everybody can understand that. And please don't forget, 8 hours is not a mandate. About 5 or 6 hours is, for 2 reasons. First of all, the telephone rings. Anytime you've taken public transportation, there's always a sign in there somewhere saying, don't talk to the bus driver. You know where I'm going with this. Don't talk to the programmer. Say, geez, you know, I need you to stop what you're doing, and the client wants that turned from blue to gray. He's got to stop what he's doing. He's got to check out the new project, make sure his code is up to date, and then by the time he takes that 30 seconds to do, what happens to the 8-hour day? About 5 hours is the maximum you can get out of productive work. And if you have somebody sitting there for 12 hours, let me tell you from experience, after a while your brain just turns a little bit soft, and anything you produce after that time is going to have to be refactored the next day anyways. So it's no longer productive. What a lot of times is missing from project planning are subtasks. We need to do quality assurance. We need to do communications, and I'm going to call them non-developmental jobs. If that's factored into the planning, then you can understand later how much overhead that costs. And I'm not just talking about project managers, but about developers as well. They also have to talk on the phone. I mentioned this earlier, and this is one of my favorite little anecdotes here. What we can do is go to the client and say, well, I have one designer, I have 2 developers, and the project manager is going to take his 20%. So if I have this team working on the project for 6 months, it's going to cost you that much money. This is called the headcount method, and most time and material projects run on this basis. Unfortunately, when due dates are involved, or when there's a set budget, this method has its problems. For instance, are there tasks within the project that have a set minimum duration? For instance, you have to do a deployment which always takes an hour, as a guess. Maybe anybody can do it, but it doesn't matter whether the expert does it or the novice, it always takes an hour. On the other hand, there are jobs within the project which only one person can do. That means that person's specific, and it doesn't matter how many developers you have, if you don't have that one key developer, you can't get your task done. Oftentimes, especially at the end of the project, and this is a phenomenon I've witnessed many times, panic is approaching, the project is getting out of the happy phase and turning into more and more of a crisis. All right, we're going to pull him off the other project and get him up here. We need a new project manager. We're just going to double the team size. Everything's going to go twice as fast. This is my second bullshit. It won't. It will slow things down. I'm sure many of you have heard the popular expression, you can't have 9 women produce a baby in 1 month. The more people you have working on a project, the slower it gets, because you have higher communications overhead, you have a larger quality assurance mechanism that you have to use, and there are other reasons as well. So, most of the methods I've discussed up until now have been waterfall methods. Also Wasserfallschätzung, kennen wir doch alle. Now we're moving a little bit out of that into agile estimation methods, and these, I think, have a better chance of success. When you're doing waterfall estimations, that means I have the project manager, does the whole project using Microsoft Excel. I have the UX designers, they use their wireframing tools. And I have the Photoshop geniuses in design, they do the whole project in Photoshop. And the front end comes along, they do the whole project using whatever front end technologies they might want to make a nice front end prototype. Then it goes into the back end, the project is done for the 4th time. Each individual member of the team has had to deliver an estimation alone. How long is it going to take you to do that design? You, Mr. Front-ender over there, how long is it going to take you to make this little teaser with the buttons just the way I want to have it? Can you reckon that out, please? It's always a poor way of doing it because it's not a team effort. The entire team, like I said in slide number 1, is responsible for generating the complexity of the project, starting with, and nobody really wants to admit this, the customer. Everybody generates complexity. So we have maybe 10 people in the entire project, all of whom are generating complexity, and you go to the designer and say, how long does it take me to do that? That is the first indication of failure. So if we move estimation away from individual task into the realm of a team job, then we have to force everybody to think. We have to force everybody to think not only about his own tasks, but everything else. We may see complexity in other areas and other technical areas of the job we hadn't anticipated it. So we sit there and we do an estimation as a team. And this is an agile method. Some people call it Scrum. Some people call it planning poker. We'll be getting into that in a minute. All of these different methods force us not to think as individuals and to look down at our shoes and say, I really have to prove my technical expertise and give an estimation, but I can do this as a team. That way, if we run the project into the wall, we've done so as a team and not as a single member. And any time you're sitting there estimating a task within the project and there are strong variations within the estimations, you know that there is confusion. Just like I said about 5 or 6 slides ago, communication has failed. I also said we make abstract and comparative estimation values. I'll be getting into the actual numbers in a minute, but we want to estimate complexity, and we want to estimate comparatively, because this is a much more complex task than that one. How do I know that? Because we all reached this decision together. Later on, in just 1 or 2 more slides, we're just about done here, we can actually put numbers into the estimations. Does anybody here know what Phyllotaxis is? We had a couple of academicians here. Come on, hands. Phyllotaxis? No? Nobody? It's not important. Forget it. Fibonacci, however, is. When we are generating our comparative estimates, it helps to use a set of numbers which aren't linear in progression, but which are geometric or organic in progression, to more starkly contrast the levels of complexity which are being estimated. If you're seeing there's a whole team and you are putting numbers to abstract complexity onto individual tasks, you can force people to think comparatively. I don't know, is that minutes, hours, cups of coffee? I don't care, as long as people understand what the level of complexity is. And they're far enough apart that we can force people to think in terms of comparison. And at that point, we have reached the first level of success. People are thinking of comparatively, and let's say everybody has an individual task and they say, okay, this is as far as complexity is a 13. The next iterative process, let's say we're planning and executing the project in sprints. A similar task comes up, and we know from the first sprint that we were off on the estimation. It was too complex, it was too easy, that we can correctively adjust our estimation to come up with a better estimation for further in the project. This is where we're going to get a little bit more detailed. I'm sure many of you people who have been working on agile projects have seen similar descriptions already. What we do is we take those abstract values of complexity and we map them to the actual reality. Did we have a complex task? Was the task easier than we thought it was? We take the entire number of complexity points that was involved in a single part of the project and say, okay, we managed to do this. We predicted we'd do maybe 100, but we only made 90, or maybe we did 110. Then we can move to the next sprint and correct our estimation. And then finding out how many actual hours went into the generation, to the rendering, the programming, the production of these story points, then we know how much time and effort we've spent. Fine, the first sprint is going to be inaccurate, maybe even the second one, but as the project continues, then we will achieve more accuracy. In classic Scrum and Agile methods, there are also mechanisms in place for dealing with complexity and uncertainty. We talked about that at the beginning of the presentation. Something new comes in, how do we factor that into the complexity? So I'm just about done now. As you may have seen the symbolism that I had in the project, I picked one big project to illustrate what I'm talking about is the initial moon landing on July 21st, 1969. Kennedy said, I want it done by the end of the decade, and they made it. It was a bit more expensive than they originally planned, but they tried to estimate it, at least. The original code used to fly and monitor all the systems on the Apollo rockets can now be downloaded. It's about 420,000 lines of code, for anybody who wants to read through it. Yeah. So, at that point, I'd like to say thank you very much for listening so quietly and interestedly. Does anybody have any questions about that? Auch auf Deutsch?
Ja. Fragen? Aber ihr kennt alle schon Scrum, also von daher, und agile Softwareentwicklung und iterative Software. Ja. Also es macht durchaus Sinn, sich mit sowas zu beschäftigen wie dann.
Ja?
Eine Frage?
Ja? Eigentlich habe ich nicht damit gerechnet, dass jemand eine Frage stellt.
Ich fand es sehr spannend mit der Idee, mehr im Team direkt die Schätzung gemeinsam zu machen, aber ich kann mir noch nicht ganz vorstellen, wie es wirklich komplett nur im Team stattfinden soll, weil es ja schon Sachen gibt, die man sich dann einzeln anguckt und sagt, da schaue ich nochmal nach, wie würdest du damit umgehen oder was
Ich müsste mich tatsächlich damit auseinandersetzen. Das wird auch, es ist auch Teil meiner nächsten Präsentation. Wir machen dann eine Zeitreise, das heißt, im Teamplanung, wir sitzen da mit Designer, wir sitzen da mit User Experience Architekten und alle möglichen Leute, die völlig verschiedene Fachrichtungen ausüben sozusagen. Und wenn ein Datenbankentwickler die Komplexität vorstellt und der Designer sagt, wie soll ich das bloß überhaupt schätzen, ist die Frage sehr berechtigt an der Stelle. Was wir gewinnen aber dadurch, ist ein gegenseitiges Verständnis für die Komplexität der Aufgaben. Das nächste Mal, wenn ein User Experience Architekt eine Änderung vorschlägt, das auch eine Datenbankabfrage beinhaltet, weiß er schon Bescheid. Momente mal, das letzte Mal fingen sie an, schwere Gegenstände zu werfen. Das ist genauso, wir sitzen da auch im Agenturleben oft im Team zusammen mit völlig verschiedenen Fachrichtungen. Alle müssen sich gegenseitig so ein bisschen ihr eigenes Fachverständnis beibringen. Und das ist letzten Endes sehr, sehr hilfreich.
So, gibt es noch weitere Fragen? Okay, dann vielen Dank.
Sehr gerne.
Vielen Dank für den tollen Vortrag.
Webmontag.